From Olympic City and the home of Pikes Peak, this is the Automotive ADHD Show. Oh yeah, here we are, rocking it for another edition of the Automotive ADHD podcast. Matt West here. Want to thank you for joining me to talk about cars. Yeah, talking all sorts of cool car stuff today. Toyota did something really fantastic. You could say they're truly cultured memers now. Also, going to be talking about a few other things, how you could buy a drag strip, and most importantly, the last segment of the show, going to be doing an interview with Wesley Kagan, an engineering madman, YouTuber, and good friend of mine. He's going to be talking about how he DIY'd Koenigsegg's Freevalve technology onto a Mazda Miata. This is really cool. You want to stick around to the end of the show for that. But before we get into that, ladies, gentlemen, Honda S660s, let's talk about that drag strip I was mentioning. So a hat tip here to Josh Maldonado, who posted this on the Automotive ADHD Facebook page. And up for sale right now is a quarter-mile drag strip. It is in Ohio. It is complete with the timing tower. It's got grandstands, can fit about 300 people, working Christmas tree, not the festive kind, you know, the timing tree. It's got that, tons of equipment, 2 tractors, a track sprayer. Oh my God, so much stuff. Basically, all of the equipment you could ever need to run a drag strip successfully. It's also got 1,000 square foot heated and cooled shop space. I'm not done yet. There's another 1,000 square foot building that is furnished as a house on the property. That is so cool. So you could live there. You have your shop there. You have your own drag strip. You've got tools. You've got everything. And okay, it gets even better. I'm going to keep going because it gets better. There are, where it's at in Ohio, there are no sound ordinances or curfews. So you could be up there doing car stuff, being as loud as you want. No one will care for the small price, by the way, of $690,000. It's a sort of small price. I mean, look, there's the price to pay to have your own drag strip. Now, this isn't just, your own drag strip. I mean, this could be run as a whole business, have people come in on weekends. I'm sure if you ran events from this, you would pay that mortgage just like that. It would pay for itself, essentially. So, yeah, time to sell the house. Time to sell the house. Go buy a drag strip in Ohio. That would be really cool. And I mean, $690,000. I mean, who am I kidding? That's like the price of a small 1-bedroom condo here in Colorado. That is, yeah, it's a lot of money. But when you think about it, think of housing costs now. You could go buy a halfway decent house in California. Or that probably, I don't know, that probably gets you a shack in California. But you could get a nice, decent house, or you could have a drag strip, which also has a nice house on it and a shop space. Like, see, I would just rather live in the shop space, but that's just me. But yeah, good stuff right there. And that is posted up on the Automotive ADHD Facebook page. Go check it out. Lots of good stuff going on there. Also, another thing I want to get into really quick before we get into the meat of the show, I have a interesting piece of paper right here. And this is funny. This is a toll. A road toll. I was driving my 86 to visit some friends up north of me in Denver, and this toll is hilarious when you actually read it here, because I'm like, why did I get a toll? Because I usually avoid toll roads, and so I looked at it. The toll, it's very small. It's for $5, and it's for entering one section of road. They show the time, October 19th, and this just came in the mail, but October 19th, 6:05 p.m., 47 seconds. Leaving 6:07 p.m. and 20 seconds. Like 90 seconds I was on the road. And actually, and I'm not complaining about this, I think this is hilarious, but I was actually, I got boxed off in the middle of really bad rush hour traffic. Denver, of course, is the capital city here in Colorado, and traffic there is insane compared to, what I'm used to. And so I got boxed off in some construction traffic and had to take the exit for the toll road. I was like, oh, come on, I hope they don't give me a toll. And then I literally went through the toll booth, turned around in the median where I was able to turn around, and then went back up the toll booth to get back on the highway. Yeah, $5 was on there for a whopping 90 seconds. I don't know. Here's the question then. Should I pay this? Should I really pay this? I mean, yeah, it's $5. I have $5, but out of principle, should I at least try to contest this? You know what? I don't know. Maybe you can decide. Feel free to let me know on the Automotive ADHD Facebook page. I guess you could call this, quote, highway robbery. Ah! Oh, I'm sorry. Yeah. On that note, I think I'm going to see myself out the room there. Yeah, no worries. By the way, we are going to be getting through some of these first segments. I have a few more topics I want to talk about, but we are going to be going through it kind of quick on the show today, quicker than you're probably used to, because I want the last segment of the show to really be able to feature my interview with Wesley Kagan. He is waiting patiently to get on the show. So we're going to get through a couple more things really quick and then get to the meat of this interview. You really don't want to miss that. In the next segment, I'm going to be talking about why Toyota is the king of memers, so far as at least the auto industry is concerned. That's coming up next.
'Twas the night before Christmas when all through the house not a creature was stirring, not even a mouse. The children were nestled all snug in their beds, while visions of turbos danced in their heads. When out on the lawn there arose such a clatter, I sprang from my bed to see what was the matter. When what to my wondering eyes did appear but a Mark IV Supra with boost to hear, and a little old driver so lively and quick, I knew in a moment he must be Saint Nick. And then in a twinkling I heard the tires screech, the prancing and pawing of each horsepower. Down the track St. Nicholas came with a bound, a bundle of parts he had flung on his back. He spoke not a word, but went straight to his work, and filled all the stockings with speed parts and more, for the children would not have to return the core. He sprang to his Supra, with tires to roast, and down the track he went making the most. With 40 pounds of boost on tap he tore, knowing the children would soon have more. Saying Merry Christmas from the Automotive ADHD podcast. Ho, ho, horsepower.
Yes, indeed. Merry Christmas. Happy holidays. I may or may not have used the Patreon fund to hire a voice guy to read that, by the way, to do that spot. So good stuff right there. Also, those car sounds you just heard, those are courtesy of my buddy Jesse and his AP1 S2000 supercharged. That was a video of it. It's now turbocharged, actually, is what he says. And it's very cool. I've seen it with the turbo. It's amazing. But that was when it was supercharged. He just sent that into the show. Those car sounds, of course, could be yours. If you have car sounds and you would like to share them, remember that the Automotive ADHD Facebook page is always there. And there is a post pinned on there where people are sharing their car sounds. And in the future, too, I am going to be perhaps doing some giveaways for people who do share their car sounds. So that's coming up soon, though. Now, I want to talk about Toyota. I've talked about them in a few podcasts. Now, they are one of my favorite car companies, though last week I did call them out on some total garbage nonsense that they were doing with subscription services and wanting you to pay more money monthly to use mechanical features of the car. I think that's ridiculous. But if you want my take on that and you missed it last week, go listen to last week's show, but not after you listen to this week's show with the interview with Wesley coming up. You got to hear that. But so Toyota did something pretty interesting, and this comes from The Drive and one of their journalists, Rob Stumpf. And he was at a press conference where Toyota debuted 15 electric-only concept cars, but that's not what's important here. What's important is on one of said concept cars is a little screen on the front of the car. That's kind of part of the idea. You could put, little smiley faces or something on the front of your car at the screen. I don't know. But on that screen was a QR code. And when one scans that QR code, it plays a particular song by Rick Astley. You know the one. Yeah, never gonna give you up. Never gonna give you up. Yeah, that song. Yep, and so Toyota rickrolled dozens of automotive journalists at their press conference, and I think that is amazing. That is genius. I mean, that was, the Toyota CEO was just standing in front of that car, talking about it, and everyone's looking at, ooh, and then someone decides to scan the QR code, and they get rickrolled. And by the way, if you're unfamiliar what rickrolling is, it's a meme, an internet meme from like 2008. It's a really, really old meme, and I think it's hilarious. And yeah, I still rickroll my friends. Does that make me old that I like these old memes? I don't know. But again, it's the whole point of the rickroll meme, again, if you are unaware, is that you send somebody a link to something entirely unrelated or something that they're interested in. Like, say I sent you a link to, I don't know, Mark IV Supra videos, and you wanted to see that, right? And then you open the link, and instead of what's titled, it plays Rick Astley, Never Gonna Give You Up. And fun fact, by the way, and some of you may know this, but I work in radio as part of my day job and commercial radio. And at one of my last radio stations I worked at on my last day, I will say this wasn't on the level of Toyota. I'm not as cool as them. But on my last day at work at one of my radio stations, I did rickroll probably about 20,000 people who were listening at that time. I just last song, oh yeah, here it is, and then it was Rick Astley. Maybe in the future I'll dig that audio out and make that a Patreon exclusive. But anyway, with Toyota and their concept cars. Getting back to that, aside from the memes, aside from the Rickrolls, I do like Toyota just a tiny bit more now that they did that Rickroll. But they really should cut out that subscription service thing that I talked about last week. Anyway, I don't really, with their concept cars they debuted earlier this week, I really don't like talking about concept car news because concept car news, the concept cars themselves are always really far from what potential production car might exist, and usually one never does. I mean, we're talking like 15 years apart sometimes. Not saying that concept cars are unimportant. They do show exactly what they do, which is a concept. They're not meant to represent a production car. So yeah, they're interesting to look at from a, looking toward the future perspective, but I also think that it's kind of boring to talk about, quote, concept car news. That's not really my thing. I will say, of their lineup, of these 15 cars that they had, what looked interesting, because most of these cars were boring crossovers. Ooh, they're crossovers and they're electric. Like, we already hate crossovers in the car world, right? Because they're so boring. And as more and more electric ones come out, those are going to be even more boring because the only moderately interesting thing has been removed from it. But I digress. Some of the interesting cars they had was this weird little panel van they came out with called the Microbox. It's kind of weird. And then also what looks like an electric Tacoma. And I actually, get this, I like that because I think trucks are perfect for electrification. I mean, perfect, because what you want in a truck, torque. What do electric cars have? Torque, lots of torque. And electric trucks are bigger, they're boxier, they can hold more batteries than like an electric sedan would. So I like trucks. I like big trucks, gas trucks, diesel trucks. I do like them. But if anything were to be electrified and actually get a true benefit performance-wise from it, I think trucks would be first on my list for that because, again, just sheer amounts of torque. And that could be good. Toyota also had a MR2-esque looking sports car. Are they really going to bring back the MR2 as an electric car? I hope not. And maybe as a hybrid, that would be cool. But I don't think sports cars should be electric. Sports cars are meant to be exciting. They're supposed to be engaging, and they're supposed to engage the driver. And electric just doesn't do that for me. They also had some interesting cars as far as like commercial vehicles, like delivery vans, like industrial little trucks for like the Japanese K trucks they already have for moving things around. Those like mini trucks, they had an electric one of those. I see a benefit from that. Like electric cars, again, I think trucks will benefit from it. I think commuter cars will be very beneficial. I mean, and Toyota here, what I like is they said that they're not going to go full electric like some manufacturers are pledging to. They said and I agree with this, that they believe in consumer choice and that the consumers should be able to choose what they want, a gas car, a hybrid car, or an electric car, and not have governments tell them what they can and can't have. And I think that makes sense because if I want a sports car, I want a gas car and I want one with a manual. If I want to build an overlanding off-road rig, I want a gas one because I can carry extra gas with me and fill it up on a moment's notice, or have a buddy if I get stuck or run out of fuel, a buddy can come to me with a gas can and bail me out. Can't really do that with an electric car. But if I wanted an around town commuter or a highway commuter for, like an hour commute or something, I would go electric. Absolutely. If I wanted a torque monster pickup truck that's really fast and fun, like that new Hummer EV, yeah, electric. There you go. I just, picking the right tool for the job, I think you're going to have a better time doing that than just saying all things should be electric. No, there's still a very good reason and an efficiency reason, too, to have gas stuff. So I think that's cool. But no. The takeaway here, again, is that Toyota rickrolled everybody. And I think that's amazing. So, yeah, there you go. Now, I don't want to keep my guest waiting any longer. So coming up in the next segment, engineering madman, a YouTuber, a good friend of mine, Wesley Kagan. He will be here in just a minute.
Did you know there's a rare but serious condition affecting 1 out of every million? Most are born with it. And despite decades of research, doctors struggle to find a cure. The truth is, thousands of people simply don't know what cars are. For those affected, things are grim, but recent developments show promising success. New clinical trials using breakthrough audio technology have shown a 69% improvement in patients with the most severe symptoms. Treatments vary, but one day we may see a cure. More information is available at throttlewarrior.com.
Yeah, here we are, rocking it for the third half of the show. Matt West here, hanging out with you for another great edition of the Automotive ADHD podcast. Those car sounds, by the way, are courtesy of New Long Lore. Hopefully I'm saying your name right. In his Honda S2000, he posted those car sounds on the Automotive ADHD Facebook page. And if you've got car sounds to share, you can also post them there if you would so like to. Now, I know we're a little S2000 heavy today on the show. There's nothing wrong with that. I play the car sounds that get sent to me. So, and also those clutch kicks sounded awesome, by the way. Now, that said, I don't want to waste any more time in getting to my next guest, who is joining me from Phoenix, Arizona, longtime friend, engineering madman, successful YouTuber with over 4.8 million views. Now, he's been featured on Car and Driver, The Drive, Jalopnik, Donut Media, and more. Wesley Kagan, welcome to the show.
That makes me sound a whole lot better than I actually am.
An exciting intro there, right?
Wow. Yeah. No, I'm honored.
It's good stuff. And now you've been, before we talk Koenigsegg style Freevalve and how you've adapted that to, the DIY aspect, let's talk about some of your other cool engineering projects. You've been up to all sorts of interesting stuff. Namely, what comes to mind to me is the Porsche cart now turned Mercedes cart, home built F1, style race car. Let's talk about that.
Yeah. So the Mercedes cart got the V12, and the thing I really love about that car is that it's kind of the never-ending project. Like, I don't feel, especially since I've done some videos on it and it's not going anywhere. I'm keeping that car forever. I really enjoy having it as kind of the never-ending project. It's always going to get little tweaks here and there. I did the F1 suspension on it that I'm still fine-tuning and doing some stuff like that. And it's something that I really enjoy. It's a fantastic test bed for these little projects that I have. And I actually have a project that I'm working on with a friend of mine who's doing some racing. And I'm going to incorporate some of that F1 suspension, that variable suspension that I designed for the Porsche cart, and fine-tune it on some hot laps, just because that car is a lot more consistent.
Well, and to be clear, like you built that car, from the ground up, right? I mean,
from scratch,
from scratch. This isn't a chassis that already existed. I mean, this was 100% built like a 70s F1 car in your garage. And now again, it's got that V12. So it's, we started with the Porsche engine in it that died a little bit, as I recall. And then a V12 ended up in it somehow.
So like the story on that car is such an interesting story, in my opinion, because I really didn't start it or build it with the intention of filming a YouTube video with it or doing anything with YouTube with it. I really it was whatever it was, January of 2020. I had an idea that I was like, I want to build kind of an open wheel tube frame race car. I knew the Boxster platform, the 986 platform, really, really well. I started to go through and I found a super cheap Boxster that was in Phoenix. I went through, I did the engine in it. And I kind of used that as a base to kind of build the rest of the car out of, and use the 986 as, for parts. The steering rack is still just a cut down version of the one that came out of the Boxster.
Right,
the radiators are from a Boxster. It's a ground up build using basically one car. I think there's a Jeep throttle position sensor on there.
Well, and you also put, just as a joke, I remember the Jeep wheels on it because they just randomly, which that looked amazing with the 33-inch Jeep tires on it, just as a standing type of thing.
And when that car is running, I still have to finish exhaust on it, and I think just exhaust. I think it's getting pretty close there.
Nice. Yeah, I was gonna say too. I mean, you had over like 1 million views on your YouTube video of that car, which is insane like too. I mean,
it's I mean, and that really started this entire thing. I mean, I'm incredibly grateful to everybody watching me be a moron on the internet. It's very cool that people were interested in it and allowed me to go on and do some of these other projects. Because it really was a game changer in that regard. And I mean, a lot of the big projects that I do, including the Harbor Freight Freevalve build and stuff like that, were born out of this idea of, well, we can give that a shot and see what it does. And
that's always the best type of like project, right? Like well, can we do it? Yes,
absolutely. Yeah.
So we should do it then. Yes. A because we can, we should type of mentality, and that leads to some of the coolest projects and some of the neatest things. So now let's get into the main thing here, which is that Freevalve technology. So you rather famously put the Freevalve technology, and we're going to kind of get into what that is and why it's really cool. But you put it first on a Harbor Freight motor. And then on a Miata. So, and some of my listeners might be hearing about Freevalve for the first time. They might not be as aware of this. So can you break down real quick kind of how a conventional valve setup works in an engine, what that does, but also how the Freevalve really differs from that?
Sure. I mean, the basic understanding of a camshaft obviously you have a controlled environment with a piston going up and down, you have a combustion chamber, and you have to have a way to get A, air and fuel into the combustion chamber, B, create a seal in order to create combustion, and C, get the spent fuel and exhaust gases out of the combustion chamber. So the traditional way that has been done since the introduction of the internal combustion engine is to have a camshaft of some sort. And that's not just limited to internal combustion. Any heat engine has to have those basic principles, or mostly has to have those basic principles. So a camshaft of some sort to introduce the fuel air mixture and get the exhaust gases out, or provide an opportunity, or provide a direction for those to get out, I guess.
Right, and for the the camshaft, this is something that any production car right now, aside from the weird Tesla fanatics, I mean any combustion engine car has that, and that camshaft is really a way of opening and closing the valves. Turns the rotational force through a weird egg-shaped kind of piece of metal and opens and closes a valve, that way. And the valve, and I think the best way to describe this, this being, sort of a non-visual medium here, but the best way to describe a valve to, again, for people who might be hearing about this for the first time is like those little, those suction cup guns you had when you were a kid and they shoot the little suction cup out. So it's like you have that suction cup in the stem. That's sort of the shape of a valve that pushes up and down to allow air in and out. So the camshaft is doing that. And where your Koenigsegg Freevalve differs is the fact that there is no camshaft.
Well, exactly, because a camshaft has two distinct downsides. First of all, it is a parasitic drag. The other part of it is in the fact that it does rob horsepower. The other part of it is that there, for the most part, is a set. You're limited to one parameter of how you want those valves to open and close. You're limited to one way that those valves can open and close per engine revolution. The exception of that being, of course, Honda VTEC or anything similar to that, which, correct me if I'm wrong, I don't own a VTEC product. It actually shifts the entire camshaft over to a different set of lobes. Is that correct?
Right.
Yeah.
And yeah, that's something that I have, I would say almost regrettably, a little too much experience with.
On the S2000.
Having blown up my S2000 like 3 times now.
Yeah.
But yeah, what that Honda VTEC is doing is it's taking those camshafts. You have 2 different cam lobes that interact with the valves on one side. So say on the intake side, you've got 2 cam lobes, and those lobes are responsible for opening the valves a set amount. And when the VTEC engages, there is a 3rd lobe in the middle of those. And that has an extra rocker that it's going against that's not pushing against the valve. And that rocker, once engaged with a oil pressure, there's an oil pressure switch basically that puts a pin through all of the rockers and locks them to the middle one, which is where the big cam lobe is. And now that bigger one is enacting on the valve. And so the net result here is that bigger cam lobe is opening the valve further. So it's opening it up a further distance, but it's also opening it up longer. And the benefit to that, again, is that you have more airflow going into the engine. And the reason you would do that as opposed to just having one really good camshaft, because, I've heard people ask, well, if you have this VTEC thing, why not just have the big lobe be the main lobe all the time and always have the more airflow? But the fact is that more airflow is only really more efficient at higher RPM as opposed to, and it would be a downside. It would be less drivable just putzing around traffic. In fact, it would be awful. And I think people who do big cam swaps into, like muscle cars can attest to the difficulty idling sometimes.
Yeah,
So,
I mean, realistically, your goal with a heat engine is to get the most amount of power out of the fuel that you're putting into. And most camshafts that exist on the open market for aftermarket have a specific goal in mind. I mean, you can buy a horsepower cam, you can buy a torque cam. Most cams that are put into production vehicles have an emissions goal in mind, or a goal that is pretty good at everything and not good at one specific thing, which, considering the technology, and we have to remember that camshafts are incredibly cheap to manufacture, all things considered, and very efficient in going about what they do.
right.
What Koenigsegg has shown with Freevalve is that can be improved, and the showcase of their products over the past few years has been fantastic in what they've done, increasing horsepower, increasing torque, increasing engine efficiency through the use of Freevalve. So Freevalve really replaces the camshaft and takes an electropneumatic actuator to open the valve and introduce air into the engine or exhaust gases out, and then close the valve in a much more precise and much more controllable function. And that can absolutely increase engine efficiency in pretty much every situation. It also has the benefit of being able to open and close certain valves other than what are presented on what you would see on a normal camshaft. So like they're famously using, instead of a turbo wastegate, they're opening the exhaust valve a set amount instead of using a turbo wastegate to control exhaust gas flow into the turbo. and then having the other valve on a 4-valve motor go to the regular exhaust, which helps the catalytic converters warm up in a more controlled environment. There's a lot of benefits. I can tell you, I want to be very clear in that they are a lot better at designing things than I am.
Well, one thing too is, I mean, like Koenigsegg, and I looked this up earlier. Christian von Koenigsegg, he's got a net worth of about 125 million, give or take on any day. That's just him. That's not even his company as a whole. So they have a lot of resources to be able to design this system that is totally revolutionary. I mean, there's never been a system really like this before, and relating this to, passenger cars, the casual listener might say, well, why do I care about this? Because this is something that is basically the first time we've seen such a significant change in the way a combustion engine works in, 100 years, right? So that's why this is cool. And you can improve efficiency, you can do all sorts of stuff, and you can improve performance. Now, again, Koenigsegg having 125 million net worth, is a lot of resources, a company, design teams, engineers, and they build some amazing things. How did you get this working on a more humble budget?
Very, very carefully. No, it's I set out with a goal in mind, using the basic parameters of the forces required and the speed required. The speed was the big part of it. To really, my goal to start out with a Harbor Freight build was just to get it running. Obviously, moving on to the Miata, there was a big increase in what I wanted to do with this system and everything like that. And keep in mind, not without significant amount of trial error problems and things that still are not fixed. I mean, I can honestly say there's a reason why I'm exploring other options outside of electro-pneumatic control, because with my resources, both financial and ability to manufacture, because my ability to manufacture is, I feel, pretty good for a 2-car garage in the suburbs.
You do this out of your garage with like a lathe and a drill press and some hand tools.
Yeah, my ability to manufacture, I don't have a 5-axis Haas mill sitting in the corner just doing nothing at any given moment.
Yet.
So,
right, yet.
Yet. If anybody, Haas, if you're listening, sorry about the F1 thing. My ability to manufacture is not as good as one that has the resources available, like Koenigsegg, to do. So that's why I'm exploring other options. I mean, a few of the big things that I ran into on development, interestingly enough, speed control and stuff like that really wasn't, like, considering what we can do with technology and considering how available cheap processing power is anymore. When it really comes down to it, because an Arduino can do a whole lot, a Raspberry Pi can do a whole lot, and that's a recent development in the last 5 years on how cheap processing power really is.
Right.
So that's less of a concern than really the physical properties of what you're trying to do, because when you're moving a stationary object like a valve against external forces, you have to get that valve moving very fast in a downward trajectory going into the engine against the pressure of the combustion chamber that just exploded fuel and air and created forces going down. And then you also have to get that valve to either A, stay there, or turn around and come back out in fractions of a second.
Right. And didn't your earlier design, I remember one of your earlier designs was using still valve springs. So with a camshaft, that cam lobe goes down and, basically pushes the valve open. And then there's a spring that pushes that valve back closed when the cam is, back when it's turning around and it's no longer pushing force on the valve. Now, so your earlier setup, you used a valve spring still, but didn't you later go to a push-pull type of setup?
I created a device that attached onto the end of the valve where the valve spring would have attached. And it's actually, still to date, probably one of my better designs. I hate to say it. And with it attached onto the end of the valve and everything like that, that was able to hold that to pull it back up just as a valve spring would. But again, I would have full control over it instead of sending it, instead of having the spring to come back against it. Because something you have to realize is that a valve spring, like all of that force has to come from somewhere. I would be fighting not only the compressive forces within the combustion chamber, but also the force of the spring trying to open the valve. And then at a certain point, at a certain engine RPM, the valve cannot close fast enough, and you get valve float because the spring can't push it back up fast enough. You solve that by putting in a heavier spring.
But then that means you need more force again to open it. And if you're using something not as mechanical as a camshaft, then you have to have something strong that can impart that force accurately
exactly.
and quickly.
And I mean, controlling a force with no load on it or very little load on it is way different than controlling a force with 55 to 60 pounds of force against it as that valve's opening and closing. So it becomes a lot more, it genuinely becomes easier to put it into a push-pull situation from a control standpoint than it ever would be to run a valve spring. On the Harbor Freight Freevalve build, I wasn't operating in a language of precision as much as I was on the Miata build. There's a lot less precision in something like that.
Right, and you kind of did that to prototype the concept initially,
Absolutely.
right? A couple $100 and you get one of those. I mean, it's basically like, a lawnmower engine.
It is a lawnmower. It's not even basically.
Again, my guest is Wesley Kagan, and so you went from then a lawnmower engine to then putting this on a Miata. Now, the important question is, why a Miata?
Well, you're setting me up for it. Miata is always the answer.
Miata is always the answer. There you go.
Pop-up headlights.
Miata is never the wrong answer, especially an NA Miata. Those are good.
Exactly. And I mean, that's, A, I wanted a Miata, and this was a great excuse to get one. B, a great example of why I chose a Miata is that before I even got a Miata, I was prototyping the design. I was trying to pick an engine on what to prototype design on. I called a local Miata store, Miata parts warehouse here in Phoenix, and I was able to get, I think I got two. I think I got a 1.6 head and a 1.8 Miata head for like $100.
Nice. Did you tell them what you were gonna do to the heads?
Oh yeah. So like I got both of those. It just became so, parts availability was cheap. It's a good just general platform. Also, there's 4 cylinders and not 8. I mean, there would have been a lot more control issues with a V8. A 4-cylinder is a lot simpler as far as when you're focusing on the basics of construction.
Right.
The other part of it is that it introduces an entire, and one of the most exciting things that I saw out of it was that it introduced an entire subsection of tuning that allows a lot to be explored. Like we do a lot with fuel and air tuning already, and different intake setups and optimizing airflow and fuel delivery for a specific engine. This allows that to be fine-tuned even more to the point where you can do a lot more with it.
And I think that's really cool. Now, what are your, so I mean, this is a continuing build. Like, this is never ending. What are some of your future plans for, continuing to develop this system? What would you like to do differently going forward?
Spoiler alert. No, I think I've personally reached what I can possibly do with electropneumatic control. I think I've reached the limitations of what I can personally do in my home shop. I think that given the resources that especially a company like Koenigsegg has, I absolutely believe that there's a lot you can do there. However, I'm exploring a few different methods that have actual physical mechanical control of the valve with full control of opening and closing without actually any electropneumatic control or any electric control as far as solenoids or anything like that. It's actually all driven by stepper motors, and it's a little bit different than the one I did a few months ago as well.
Really?
So, I mean, the reality of it is that I'd really, really like to reduce some of the wear components that are that especially plagued my system. Because, I mean, there's a lot of wear involved with what you're doing, not only on the solenoids themselves, but on machining tolerances, and as much as you can limit that would be fantastic. Also, solve some of the general valve train problems that you see by opening and closing a valve directly instead of having it rolling along a camshaft, like the little bit of bounce that you get on the opening and closing of the valves when that valve seat slams back down against that seat and you're actually pulling against that. You don't see on a traditional camshaft, you really don't see that because it rolls off of that, whereas in the Freevalve stuff, when you're actually pulling that back, it has the ability to generate a little bit of a bounce there. And actually in the original, if you look up the Freevalve video that was released, you can kind of see that in the directional opening and closing.
Well, and I think too, again, this is such a cool project, and again, so cool that you were able to, knock this out in your garage, hand tools, make something that, only previously the multi-million-dollar company, the supercar maker Koenigsegg did. Again, I think there's something really cool to that. That takes a lot of skill and also a lot of design and engineering. So where can people keep up with more of your projects to keep up with all this stuff?
I am on YouTube at Wesley Kagan, and I am on Instagram, also Wesley Kagan. I think I have a Twitter. It's probably Wesley Kagan.
It's Wesley Kagan on everything. So that's
it's Wesley Kagan on everything. I have a few fun projects coming down the line, and more Freevalve stuff as well.
That is good. Yeah, and I'm definitely looking forward to seeing some of the other interesting stuff you're doing. I know you've also got a fun Porsche 928 project right now.
I'm super excited about that.
I had the car sound of it. That really choppy idle on last week's show. So that was cool. But yeah, looking forward to seeing more of what you're doing, and I can't wait to have you on the show as well as you do more stuff to talk about it. I want to thank you for joining me.
Well, I appreciate you having me on. Thank you very much.
So yeah, there you go. Give him a follow. Subscribe to him on YouTube for all sorts of cool stuff. And I want to thank you for joining me on this now 45-minute episode of the Automotive ADHD Show. You can, of course, find all things Throttle Warrior at throttlewarrior.com. The Automotive ADHD Facebook page, facebook.com/Automotive ADHD. And you could subscribe to this podcast wherever fine podcasts and, this one are downloaded. And I will see you next week when I try to stop a killer tire named Robert. See you then.